Hello and welcome back to another session of serde-yaml. It's Byron speaking, and in the previous one, it was kind of a part one for more to follow because we kind of dive deeply into stuff that I didn't want to touch at all, which is mapping and how to handle maps. And then I realized, there's lots of stuff that still has to be implemented. We started with visit any. That is a generic method here that helps us to deal with the mapping key special requirement that is coming up. It's to do, and also something that kind of needs to be done now is to put in all these values or all these tags. So for now, visit any wants to have a tag with the type, then scalar details, and so on. The cool thing is the scalar details is always the same. So I can put it right in front of the value and do a find and replace on it because that's always scalar value something. Scalar value details. Yeah, that's that. Oops. So the find and replace will do just fine, and the tag is something we have to do manually. Self opts. If I can type self opts, I can't right now, sorry. Self ops, Jesus Christ. So self ops borrow, scalar value details, clone. I think that's what we want. Does this exist? It does exist. Good. And you know what? Gee, since we have visit any here, the scalar details is something we can just use, right? Right now I would do that. So let's kick this out and let's say, well, the scalar details. So self opts borrow scalar value details clone is something we know to have here. Like this. I'd say, all right. Is it always scalar values? Yes, it is, except for when it's not, which is the... No, wait, if it's a key, then we know that that's the scalar key details that we want. So yes, I think we can know this here. The only thing that we do not know is the tag, which kind of gets lost in the process. You know what? If we would be able to implement an asref, asref tag, then we could yield a, oh man, does this work? I'm thinking that we could have some sort of conversion. Yeah, we could say do a from implementation here. So this, we could do that. So basically, instead of passing on the value manually, we can implement it depending on the type. This would be a lot of boilerplate code, I think, because we would need 1, 2, 3 lines at least to do the impl from and then F64. Yeah, let's not do this. Let's just pass on the tag manually here. Yeah, I think that's what I want. It would be too cumbersome to implement using, generics. So we write dumb and simple code here. Here I should have somewhere the failsafe schema. So we have, I think I can add, let's add this right away. Where is nm tag? Here it is. So the mapping is part of the thing. And I will just use the short names here, map. I think I should put this in right away. Map is map. Then we have sequence. is it? Oh, here it is. Sequence, awesome. What else? str we have. Generic string. Oh, that's it? Interesting. That's a failsafe schema. Okay, that's what always works apparently. Or is there a difference here? No. Now we have bool. Bool is new. Bool is bool. There we go. And we have an int, positive and negative, nothing more about this. All right. Int is int, float is float. All right. Anything else? Tag resolution, I think that's all. And that's the core schema. Bool, int, float, yeah, that's it. And there are other schemas as well that, I don't know, have nothing to do with us right now. Cool, so now all we have to do is distribute this information. So char is going to be an int, obviously. Escape char. I think I would want to call this is why, because it's a single char. Oh, and it just calls toString here, which is a heap allocation. Ooh, new. But chars probably are quite rare anyway, so that doesn't really show in the runtime. Okay, visit char. This is also, it's kind of related to visit string in a way. And probably this is how you wanted to implement it here. So what about just having a buffer? Let B be this, and then we just pass it on. Oh no, wait, we can't. Can we create an str? Is this an str now? Encoding char. Okay, which doesn't support encoding char into a stack buffer. So I don't know. How would the code look like normally? Escape Unicode by Rust using Unicode encoding rules. That could also be interesting. That might actually possibly work for us. Well, anyway, I'm not thinking about that right now. I try not to. What can str do? Probably not much. It's a primitive. From string. From UTF-8 converts a slice of bytes to slice without performing allocations. So can I convert a char into its respective bytes? But must be UTF-8 bytes then. And this is something I could pre-allocate, then I can use this, which should be stable, right? Is this stable? This is stable. Yeah, let's see, char to bytes or something. What can you do from view 32? That is interesting. How do I convert a char to a byte? without heap allocation. Huh. Yeah, maybe that can be done at some point. Maybe this is something we can do at some point. Yeah, damn it. I don't think this will work. No. Let's call visit str here. Self visit str, and we provide value to string. And that is that. So that will handle all the nitty-gritty details. And I guess we might be able to do it once we have some sort of formatter for use. The same C value visit any for details, because that one has the same problems. That's the thing. Okay, so now we have this settled, but obviously we need to specify what it is. It's tag str, and now we get into the business of actually doing this. Still have to do a special version for the floating point stuff. Or null, interesting. Because if it's not a number, right? Value classify. Oh, interesting. I didn't know that exists. Anyway, I don't know a lot, as you might have realized by now. So, yeah, it's really lots of ints here. Int. Careful with the copy paste in anyway, because it's really easy to mess it up. But that looks okay in 32, in 16, I8, I size. Wow. So yeah, now we can pass this along as well, can we? Or do we want to handle it directly? Well, we could go as far. Let's look at the floating point stuff, because I was thinking that visit any, that I can specialize this. So that's the general version, right? This where t is display, and now I could have another one where t is float. Oh, if I do it like this, I must work with traits. Can I... How can I specify that this should just be for floats without needing a trait? Yeah, okay. Two things. First, see if it compiles. And then we try this. Because this can possibly compile now. Not too bad. Float. Unresolved enum variant. Really? Enum tag? Yeah, it doesn't exist yet. Function takes one parameter, but two parameters were supplied. Visit str. True. It's not visit any, it's visit str. And in a way, yeah, it selects, yeah, we will see about that. I think it's nothing that we can easily forget. You'll see how the logic should be working here. We need some custom implementations for this stuff anyway, it seems, and yeah. Expect, oh yeah, got a string. Does asref provide me with a string slice? Oh, there we go, 308. Oh yeah, let scalar value details be this. The old problem, I always fall for it, which means it's non-intuitive, SVD. Which is annoying every time it happens. But what can I do? So, never use escape string, escape char. Escape char we can kill right away. There we go. You're done. And now we can see if we can specialize visit any somehow. It's more syntactical question. And I also would like to not force myself to work with traits here, even though that might not be a problem. Do we have a float trait anyway? Or is this now all part of the numeric module, or numeric crate, which I also don't want? Yeah, damn it. It seems to be part of the numeric module now. So yeah, I'm not sure if I like this. They probably had their reason to kind of get rid of, decodable float. Wherever that is coming from. Oh, that's how they did it. 0, 1, they put that into their own traits. So, let's have a look. What does it do? The FMTF. Oh look, we have 2 different versions, which are actually the same. Do we want that? Totally not. I think the problem might have been that Eric wasn't able to get a trait going here. So generic Earth stuff wouldn't work. But let's see. So we have a classify method, and this is really what's important here. FP category. Where's that coming from? std num. Look. So is classify a trait or not? Let's figure it out. FP category. I hope classify is a trait. But this would only be a trait on floats anyway, but I would be totally fine with that. Used to represent the classification of floating point numbers. Oh, this is unstable. 0 and 1. Right now I actually work on stable, isn't that great? std num, these are implemented for the primitive numeric types. That's good, but there's not too much stuff going on here right now. 0 and 1. Yeah, so this is why. So, can I do something silly as damn it, I can't. No, I cannot. Damn it. This is terrible. So if I would consider using the num trait. Okay, let's also see where classify is coming from, if it comes from anything. Okay, it's custom. Okay, now let's have a look at the num crate. I'm willing to use it. Num macros, simple numerics, documentation. Show me what you can do. So here should be the traits that have been kicked. Rational, complex, num, float. See, there it is. And does this have a classify? Actually, we don't need classify. Num copy numcast partial ordering. Well, fine. I think. Okay, let's do this. Well, at first, let's see if this actually will work, but I think it will. So, if it's infinite or not a number. Can do. Infinite, not a number. And if it is, we do not have display on this one, but maybe num has it. Num has partial equality 0, 1. Oh, can it be that this is unstable? Or is this a 0, 1 from num traits. Ah, okay, just from here, and here it is stable, see? So I think we can use this. Add sub maldiv. Does it have a classify? It even has a classify. Look, there's nothing we have to change here. I also need display, though, because display it will use, will it? It will write all its bytes if it contains this. If it doesn't contain a dot, then you add a dot. This is something we don't actually need. We don't care about that. No. Okay, cool. So let's use the num trait where t is num float. So we shall have, where's my lib? We shall have the num crate, extern crate num, and then cargo shall be adjusted. Num come here. I hope that works in stable, but I think it does. And if not, we will find out very, very soon. And now I can just use std num. Sorry, not num. Use num. And then the FP category stuff. Yeah, we use it here now. I just want to, let's try to build it just to see if that works at all. Take your time. Oh, duplicate method. Oh, that's interesting. So I really need, I can't have specializations here. It doesn't care. Well, that's okay. Visit float then, huh? And I wonder, did it download num and compile it? No. The trait is the value is not implemented for value. What? Ah. Actually, let's remove this for now. I just want this to compile with what we have, the few additions that we made. So does it mean it has compiled num already? I didn't see it. But apparently it's there. Use num. All right. Maybe it's used in serde or something. This is why it works. Or we didn't see it. It was compiled already. All right. Awesome. So now I should be able to just F32 blah blah blah. It doesn't matter. I take this code and put it here. With a little bit of care though. So this is the part that goes here. Like that. And this will return a string slice. And now again, we would benefit from a buffer because I would love to return just a buffer here. Right now I need to do it with 2 calls to encode, which is of course annoying. So here we need yeah, here we need 1 encode. Actually, that's not true. No, this is not true. You know what? I don't think we need a special handling. Because if it's inf or something, yeah. Yeah, I think I shall remark this here. For now, I just call the base version. So I call self visit any with the tag and the value, and shall say to do. Yeah, let's just take this here and put it in just for reference. And we can even do it like this. Oops. So this will be the documentation for the item, for the parent item, which is quite awesome. So we can basically move it just where it belongs. So what do I want to say? I want to say inf and none handling is part of the YAML specification. So it shouldn't be null, but instead be the required value. There is a lot going on regarding float parsing and serialization, and we might be fine with the standard display. Oops. Standard FMT display. If we are lucky, there we go. Okay. This is just for reference. And that is that. Okay, so now I should be able to call visit float here, and these two I can kick out. Look at this. I think there was an, I don't know, there might have been an inline before, yeah. We haven't removed the empty line yet in a few cases. So F32. So that shall now be visit float, and tag is float, and that's just the same here. So the good thing is we have deduplicated it a lot, even though there's still a few to-dos here and details to figure out, which we are not even handling yet. So right now it's just the big structures like maps, mappings and sequences, and not even with a lot of the special cases that are involved. Oh yeah, back to this one. I guess since it's special and the only special one I can think of right now, I would want to go with an encode scalar here. And map this. Let bool string bool bytes be the result of this. Obviously we don't want to write this anymore, we just map it. Voila. I could even live with just putting this in line here. Yeah, that looks decent enough. Ah, come on. Like this. And now we can encode it. Fortunately without this format. SVD, and that's the bool bytes. The tag shall be what? It shall be tag bool. Awesome. So that deals with everything that we know so far. Unfortunately, I mean, this basically means that since we have this mapping key handling a few times, that everything that goes into the mapping key handling is something that we want to put into some function that we can call. It's obvious, right? Clear. 1 to 3 times we have it, I think. Visit map element, here we just set it. Visit any, visit float possibly, visit bool, and visit string 3 times. All right. So yeah, now we have a chance. Again, I think this is just part of the refactor that I should commit. Oh, okay. Yeah. I getcha. We have to make it into a slice, which is this kind of awkward syntax again. I mean, it makes sense to me, but it's kind of awkward. This just gives you a slice, and this gives you a borrow to a slice, right? And that's how that works. No. Well, soon. It's not implemented for type U8. Bool bytes. Excuse me. So it gets a U8 here? Like this, maybe? Still gets a U8? That is odd. Is that better? I'm afraid that it would... 349, I'm right there. But I did that before, did I? I did that somewhere, come on. Here I did. And that totally worked. Encode ASCII. Can it be that I do something else here? I think that is exactly what happens. Ha! Yeah, so here we need a string. Bool str. Which is just fine. Look at that. Yeah, so encode scalar just exists in one version for good reason. And this is why we do what we do. Right now we only have a possible like performance optimization for the encode part, which supports encode ASCII as well as encode string. And right now we only have one piece of encoding, so I don't mind that. But at some point I might just kick out the ASCII version and go with Unicode altogether. This kind of reduces possibly the performance by 30%. It's kind of the trade-off I measured so far. But in our case, it probably doesn't matter because it's kind of a lot of stuff happening here anyway. So it will not be fast. I shouldn't even think about that. Premature optimization is bad, I know. I'm not optimizing anything. I just think about it. I can think about it. That's okay, as long as you don't act on this instinct. So let's run the unit test, which should panic nicely. To do complex keys. Oh look, complex keys, really? Really? Why? I thought no. Do I have to do complex keys? This shouldn't be. Mapping block 416. I think because oh, can it? Wait. So if this happens, then this means that... Oh, let's look at the code, man. What do you do here? Visit map element. Oh shit, it doesn't know. It doesn't know. It would really help if we would have a map visitor. So if I have special handling for an enum, why don't I have special handling for a struct? I could have this special handling, you know that? I could just implement it myself. But this means I have to adjust a whole lot of projects. Like serd and code. Well, probably just serd. So is there any clue that would help me to do this right? So we have a map visitor. That hands over his keys, and yeah, we don't know. The map visitor is the only thing we have, and What happens with enums again? Visit enum sequence. Visit sequence, visit enum unit, visit unit. Yeah. Oh, damn it. So this means the simplification that I thought I could make, I can't actually make. Ugh. But wait. Yeah, well, it is true. The thing is, I could check if, while in the mapping, well, I could also just not panic on this for now. This is something, you know, because I will need, oh, that's so annoying. In most cases, this will not be a problem. In most cases, we will set the mapping key and then visit map, blah, blah, will just, it is the visit that we call, right? Where is it? Here? This is what we call. And this will not call anything else. It will just call visit map element, nothing else. No, that's so annoying. But with the stack, I think we can figure that stuff out. Okay, fine. Let's put this in. Let's do it. We can figure this out. We need a stack for this though. But even without any optimizations or improvements, we can solve this with the data structures that we already have. So we have we have two code paths then. We have one that would work with actually nested structures, and one that obviously doesn't have that. Yeah, and we would start with the string implementation. From there, go ahead and have our own custom function that we will call from everywhere, because the is mapping key thing, this is something we have to deal with in multiple places. All right. I don't know what this is. Feed sir all tags and scalar values. We will now properly more or less handle all scalar values with appropriate tags. However, there are plenty of to-dos, and we will need even more infrastructure to solve to solve this properly. After all, we need to know a lot about the context to make the right decisions. And to make the right decisions and to know all that context, we need to record the context as we go ahead. This is that. Yeah, I think the next thing is the stack handling. We need to fill in the information into our stack accordingly, and right now we just don't do that. So this is stuff with the null, with information about how to handle null values, and we also need information about the depth of the current flow thing. Yeah, something like that. I will think about it while I finalize this video. Thanks for watching, and have a good day.